Hey there, this is Ozer from Team Nile. In this demo, we'll show you how the Nile Access Service, for the first time in the industry, automates the design and installation of your wired and wireless network. My colleague Shiv will demonstrate the details soon, but let me give you a quick preview. Setting up a network today involves dealing with multiple generations of software and hardware products, support contracts, and lots of documentation. When things get tough, we often turn to consulting and professional services for help. We believe there's a better way to set up an enterprise network without all these complexities. With the help of cloud software, AI, and an as-a-service mindset, we aim to eliminate inefficiencies and reduce your operational burden. Let's take a closer look at the engineering challenges involved. At the beginning, you face many decisions like choosing the right model of switches, coming up with the ideal network topology, where to place your Wi-Fi access points, and selecting the best software release made available at the time by your vendor. You manually manage configurations and software upgrade for network elements. You come up with workflows to manage vendor support tickets. After you come up with your best practices for network installation and maintenance, the real challenge of making sure that they are followed at every site starts. As you can tell, this entire process can be time-consuming and prone to errors, ultimately leaving too many things to chance when it comes to ensuring service quality. With unique innovation principles, we strive to change that. Our first principle is to innovate with an as-a-service mindset, allowing you to move at the speed of the cloud while enjoying a service level guarantee for coverage, capacity, and availability. With an integrated data model across all components of your wired and wireless network, we utilize AI to automate network operations and not just rely on it to simply summarize your task list from reports and dashboards. Now, let's demonstrate what your design and installation might look like with your next generation enterprise network from Nile. Shiv, over to you.
Thank you, Ozer. Let's take an example of what happens when a customer signs up for Nile service. We will walk you through the journey from day -n all the way to day 1 and 2. It all starts with the customer telling us where they want service. They create a site, a building, which is a physical address, and they upload a floor plan. That information then gets pushed to our backend systems, and we can create work order and jobs. The first step is to do a site survey and a site discovery. The site discovery is all about identifying where the closets are, how many racks are there, how many power outlets, fiber interconnections, etc. The wireless site survey, on the other hand, is an AP on stick survey to come up with the RF design. All this information is then uploaded to our cognitive module in the cloud that auto-generates a topology. That is how many devices are interconnected. This is where the digital twin first comes to life. It also generates an automated BOM, which we will see in our demo. We also generate a cabling plan so that the cabling vendor knows where to pull the cables and where the APs are to be installed. And also a closet interconnectivity plan on how devices are interconnected within a closet. These documents are then available to the installer in the mobile app so that he or she can do the installation. Now, once installation is done, the system looks for any deviations and does not let the installer leave without addressing them. Now, the physical part of the digital twin is online, and we use our AI to constantly ensure they're identical as all the telemetry flows back into the cloud. Now, let's go and see a live demo of what this entire process looks like. As mentioned earlier, it all starts with the customer telling us where they want service. In this example, they created a site called San Francisco. They have a building called engineering, which has a physical address, and they upload a floor plan. This information then gets pushed to our customer management portal, which is part of our autopilot apps. And as you can see, we can see the site San Francisco, the building engineering, and Suite 300. And there's a work order already been created. Click on this work order, shows all the different types of jobs that exist in this work order. The site survey job, the cabling job, and the installation job. Let's take a closer look at what do we do in a site survey. This is a view of a rack that exists in one of the closets. So we basically have a site which can have multiple buildings, have multiple floors, and the floors can have closets, and the closets can have racks, and the racks can have an asset. An asset can be anything like a fiber patch panel, a firewall, an Ethernet patch panel. We can also reserve spots for the NSP. This information gives us the lay of the land of how the floors are interconnected using fiber patch panels and where the firewalls are, where we would like our NSP gateways to plug in. This information, along with the wireless site survey, is basically sent to the cognitive module, as mentioned earlier, and that generates a bunch of BOM and NPDs for us on the Nile plan deployment. Let's have a look at the BOM. Coming back to the customer management portal, we can click on the engineering building, and you can get to see the entire BOM that was generated. The BOM is not just limited to the Nile elements, but all the accessories that are required for the deployment, including transceivers, fiber patch cables, AP mounts, etc. We also create something called an NPD, which is a topology, the Nile plan deployment. And over here, we will tell you every single element, what is its purpose and where is it located, and what is the status of that device as it's going through an activation process. All this information is then pushed to a mobile app, and this information is available in installation job. So if we navigate to our installation job, what we would see is a bunch of these documents that are generated and pushed in the mobile app. Let's have a look at some of these documents. The first one is the Nile cabling plan. This tells the cabling vendor where the AP is going to be installed so they know where exactly to pull the cables. Not only that, once the cable is pulled into an MDF or an IDF, we also tell you how to patch it to which switch. That information is all available in the cabling plan. What we also provide is a closet interconnectivity plan. So before an installer goes into a closet, he or she can gather all the hardware that's needed to do the install within that closet. In this case, it has a couple of access switches, SFPs, and DAC cables. Not only that, we actually tell you where to install this particular device, which port to connect using which transceiver, and which firewall or fiber patch panel should be connected to. All this information is available for the installation, for the installer to do the installation. Now, once installation is done, any deviations that exist are captured within the customer management portal. In this example, if I look at Nile AS6, there are a bunch of deviations that are there. And if I click on one of these deviations, I can see what the deviation is and if I should accept it or reject it. This information is all ported back into the cloud constantly, and this is where the digital twin exists in the physical world as well as in the customer management portal, and we make sure using telemetry that they're always identical.
Hey, Shiv, thanks for walking us through that demonstration. And thank you for tuning in. As you can tell, for the first time ever, we are bringing predictability to design and installation practices of enterprise networks. Hope you found it relevant to your environment. We are looking forward to continuing the conversation at nilesecure.com. In the meantime, be sure to check out the other episodes in our demo series, highlighting how the Nile Access Service utilizes closed-loop automation powered by AI to tackle wireless coverage and wired link issues, software bug fixes, and system software upgrades.